Let's carry on with deployment. Of course, the no-name platform must be deployed somewhere, right? And there are three types of deployments that are supported. SaaS, which you see the diagram on this slide. There is on-premise and there's hybrid, which we will discuss next. SaaS, what's the main benefit of SaaS? It minimizes the cost of ownership. Why does it minimize the cost of ownership? Because the complete no-name platform is installed within no-name's network perimeter. No-name Professional manages upgrades, installations, and so on and so forth. That's why it minimizes the cost of ownership. The drawback of that, of course, is that traffic, your API traffic, must now be redirected over the network, which may accrue egress costs over to the no-name platform, which is installed in the no-name network perimeter, right? It's your actual data that are being communicated. I do know that we follow best practices, TCP, tunnels, and so on, right? Secure tunnels, etc. So we follow all the best practices, okay? But some customers are not comfortable with having the actual data being communicated over the network into somebody else's perimeter. Again, the no-name platform is not interested in maintaining the actual data. The no-name platform is there to extract metadata. Just to give you an example, your API is communicating names, right? And I'm going to use my name as an example. So the traffic contains a field name colon George. That's your field, right? Name, field name, George value. That field, that value will be communicated to no name, right? No name is just going to extract George, is going to throw it away, and is going to tag, is going to associate the field name with the type string. Metadata, exclusively metadata, okay? Doesn't maintain the actual data. The only time the no-name platform is going to maintain actual data is only when it detects some kind of an incident, a finding, so that we're able to debug, okay? And again, you have all the power in the world to even obfuscate that type of information. Okay, for all that, NS201, Introduction to No-Name Platform. Okay, so the no-name platform must be integrated with your traffic sources. Okay, it could be done using mirroring. If the cloud provider supports traffic mirroring, it could be done by just the no-name platform pooling logs. It could be done by having your API gateways, your firewalls, pushing the information into the no-name platform. Okay, and again, it doesn't really matter whether it's cloud, whether your traffic sources are in the cloud, whether they're in your own data centers. The no-name platform can be integrated with all that. Okay. At the end of the day, the no-name platform, the only thing it needs is traffic. Give it traffic. That's all it needs. Network traffic. Okay. All right. So that's SaaS. Now, on the other hand, you have on-premise. Right. That's the other side of the coin. With on-premise, you maximize pretty much the cost of ownership because you own everything related to no name. You need to install it yourself, so you maximize it, the cost of ownership. You have to provision all the actual system, the hardware that is, whether it's virtualized or not, doesn't really matter, but you have to provision for all that. You have to go ahead and do the installations, perform the upgrades, patches, and so on, right? You still need to integrate with the corresponding sources like before. And the only thing that's new on this slide is the remote engine. Okay, the remote engine, usually you need to install it somewhere that is closer to the traffic sources. I don't know, you minimize latency, you increase bandwidth, right? So you install it close to your sources. The remote engine, the only thing it's going to do is going to take the actual data, ingest the traffic, discover APIs, and communicate just the metadata back to the no-name platform, which means that the amount of data that are communicated between the remote engine to the no-name platform is exponentially smaller as compared if we were integrating directly to the no-name platform. So that's the main benefit of the remote engine. Okay. All right, so that's the on-premise. Let's move to the hybrid. The hybrid is the best of both worlds, and in fact, most of our customers have a hybrid. They follow the hybrid deployment model. You minimize the cost of ownership to the extent possible by having the no-name platform installed in no-name's network perimeter. Okay, but you strategically deploy remote engines closer to your traffic sources. As you can see in this picture, we have a remote engine inside this VPC in a cloud provider, and you also have a remote engine inside your data center. And what's going to happen is the actual data, they will be communicated to the remote engine. We're going to discover the APIs. We're going to identify all the API metadata, and it will be only the metadata that will be communicated to the no-name platform. Only the metadata. We don't communicate the actual data, which means exponentially smaller amounts of data or traffic that is being communicated between your network perimeter and ours. Much smaller egress cost. You still maintain the privacy of your data because they never move from your own network perimeter into our own, and so on. Okay, you still have to now bear the cost of ownership of the remote engines, which, as we shall see, because we will be installing a remote engine, it's a much smaller piece of software as compared to the no-name platform, and it's easier to deploy. Okay, it's easier to deploy. So these are the three deployment models. Okay, now the next thing we're going to do is we're going to talk a little bit about the main components of the no-name platform. Okay, these are the main components. I can take all of these components and install it in a single system. Okay, and of course, all traffic goes through an Nginx server. By the way, before I forget, all components are containerized, and they are of the Docker kind. So this Nginx server that serves as the router, which means all traffic goes through this Nginx and then is redirected to the corresponding components, right, goes through this Nginx. So Nginx, this is our router. All traffic goes through it. Based upon the path, we have routing tables, and they reroute the request to the corresponding system. For example, you want to access the user interface, you go through management. You want to access active testing, you go through active testing. You want to push API traffic to the engine, you go through the engine, and so on. And of course, we have databases. Okay, so Nginx routing, management. What is management? This is where the user interface is at. This is where you're going to go to perform all your integrations. This is where you're going to create your workflows, your remediation strategies, and so on. This is where we're able to identify proactively misconfigurations. And of course, the output is presented to you in the user interface of all that. Active testing, it's all about testing for security vulnerabilities at development time. At development time. Not in production, at development time. And what I'm going to state next is a known fact for every single developer. It may not be known to others. Okay? Other different audience. So for a developer, it's always preferable to identify and fix a bug at development time when he's actually creating, actively working on that piece of software, on that new feature. If we wait, the code makes it all the way to production, and we find the security vulnerability or the bug at that point, it's exponentially more difficult to fix the bug. I expanded this on NS401 active testing. There's a different module that you guys can attend. For the time being, this is where I'm going to end this discussion. Okay, active testing. And finally, the engine. The engine is the busiest piece of machinery. Why it's the busiest piece of machinery? Because it's where traffic is going to find its way. It's where APIs will be discovered. It's where we're going to learn the behavior of the API, which means these are all the machine learning aspects of the platform are located at. And of course, as soon as we learn what normal looks like, we're able to identify abnormal, right? Which indicates a potential attack. Right? All that done by the engine. Okay? All that done by the engine. And of course, we have databases for storing state. Okay? State details of the Noname platform. Now, you may be seeing this as a simple component, as one component. I assure you it's not just one. So active testing has 5 containers. Management, I don't know, has about a dozen. Engine has 3, maybe more. Right? And I'm saying maybe more as a caveat. I'm not going to discuss it. I'm not going to get into that type of detail at this point. Okay? And of course, we have the databases, the Postgres and Neo4j. Right? Neo4j, in case you're wondering, it's a graphical database. Given enough permission, when you are given enough permissions, we're able to map your network pretty much in a graph, in a graphical database, so that we're able to identify misconfigurations. Okay, but of course we need permissions, and usually those are granted when you create your integrations. Okay, usually. Okay, so that's the main components. We talked about the 3 different deployment models and the main components of the Noname platform. And again, when we do the actual installation, you will get to see them all, and I will describe them to you. Right? While we're waiting for the installation to complete, I can go through and enumerate all of these components. All right, and give you a brief description. And with this, we have concluded the deployment section of our class.